How do you think? How do I think? How do we think? That's what we're going to be talking about today, so let's get into it. Hi everyone, my name is Ethan Johnson and I work in computational neuroscience, so using the computer to study neuroscience. And today we're going to be talking about how you think, and specifically one way neuroscientists use to measure how you think. So in the brain, we have rhythms. These rhythms occur from our billions of neurons firing at different rates. And we see these neurons firing at distinctive rates, which we can characterize into frequency bands. We then filter our raw signal into these frequency bands and see how these frequency bands interact with one another. Scientists have noticed that some brain rhythms will actually control other brain rhythms. One way we can measure this is with phase amplitude coupling. What phase amplitude coupling is the phase of one wave governing the amplitude of another wave. So let's talk about how we can measure that in Matlab. Alright y'all, let's get into it. So this is Matlab if you don't know. If you are wondering how to download it, I have another video on that as well. And let's get into it. So this script gives you an animation of phase amplitude coupling. So I'm gonna get it running and then explain while it is going. So we can see here we have two signals. In red, we have our gamma signal, which is bandpassed at a higher frequency. So we see it going up and down more often. And in our black, we have our theta signal, which is bandpassed at a slower frequency. So here we can see that the black signal appears to be controlling the amplitude of the red signal. So this is that phase amplitude coupling that we're talking about. We know that the theta signal is governing the gamma because based off of its phase or where the signal is at during time, we can see only when it peaks is the gamma signal having a higher amplitude. Now let's see an example of when they're not having coupling. So here on the left we see, okay, yes, the gamma amplitude is still being based off of the theta phase, but now we can see that it doesn't matter what phase of this theta signal is in, the amplitude of gamma is not dependent on it. Alright y'all, so I'm back. So this is a way that we can measure how we think and how different parts of the brain talk to each other so that we can think. I'll be talking about other measurements that we can use to quantify how different parts of the brain talk to each other and how they're connected, and how this relates to cognition, and how we can use Matlab to measure this and quantify it and to test it in science. Don't forget to like, comment, and subscribe for more content. And remember to stay curious. Alright, bye y'all.